Let's take a look at a related rates question. And imagine that this is a police car. I'll put a little red light on the top for a police car, and he's heading towards an intersection here, chasing a car. And the car that he's chasing makes a turn and is moving in this direction. And the police car wants to know how fast that car is moving, because he's obviously speeding. And so he pulls out his radar gun and measures how fast the distance between them is changing. So the question is, how fast is the car moving, the speeding car? So the information that you might need for this kind of problem is, number one, you would need to know the speed of the police car. So let's put the speed of the police car. Let's say it is moving at 60 kilometers an hour. And the speed of the car, we don't know. But the speed of the distance between the car and the cruiser is changing at 20 kilometers an hour. That was measured by using a radar gun. And the time that happened, the police car could also see that he was 0.8 of a kilometer away from the traffic light, and the cruiser, sorry, not the cruiser, the car itself was 0.6 of a kilometer away. So my question is, how fast is the car going? So I've got a really rough diagram here. What we need to do is put some variables on here. And I'm going to let this variable be y and this variable be x, and both of those are changing. In addition, z is changing here as well. So I label my diagram with all of the variables that are changing, and then I find a relationship between those variables. And hopefully you'll see that it's x squared plus y squared equals z squared. So we're using Pythagoras. And now we're going to interpret the information that's given in terms of our new variables. So the speed of the cruiser, which is the speed of this guy going down here, means that y is changing at a speed of 60 kilometers an hour. And the speed is the distance, y is decreasing. It's getting closer and closer to that intersection point. So that means that the speed is negative 60 kilometers. This means that negative 60 kilometers an hour is the speed at which y is changing. So notice how I've assigned sort of a calculus notation to the information that I've been given. This is how fast that's changing. So it's dz by dt is 20 kilometers an hour. And we are asked for how fast this guy is going, which we will label as dx by dt. And we don't know how fast it's going. That's our unknown. And we're doing that when at a certain time, which is when x is 0.6 and when y is 0.8. So let me make this just a little bit neater. I'm just going to redraw the diagram here. That's y, that's x, that's z, and I've got x squared plus y squared equals z squared, and I've got dx by dt is positive 20. Oops, dx by dt we don't know, sorry. dy by dt is negative 60, and dz by dt is 20. So now I'm going to take the derivative. So that's the chain rule. So 2x dx by dt. We're taking respect to time, so it's the chain rule for both of these. 2y dy by dt, actually all three of them, the z as well. 2z by dz by dt. And that's a pretty complicated equation, but I noticed that there's a 2 attached to everything. So I'm going to divide everything by 2, and that'll cancel these. So I'll end up with x dx by dt plus y dy by dt equals z by dz by dt. Now what information do I have So I've got my equation, I take the derivative, and now I plug in the values that I know. So I know that we're looking at a specific instant when x is 0.6. dx by dt is, I don't know, that's still the unknown. Y is 0.8 was given to us, and dy by dt is -60. Z, we don't know, but we can calculate that. If y is 0.8 and this is 0.6, we can use Pythagoras to calculate what z is. And that's 0.8 squared plus 0.6 squared and the square root of that. Or you can see this is a 3, 4, 5 triangle. So this would be 0.10. So you can double check that using Pythagoras. 0.10, and dz by dt was given as 20. So now I've only got one unknown, and I can solve for it. I can solve for dx by dt. So I'm going to have 0.10 times 20 minus, when I move this over to the other side, it turns positive, so it'll be 0.8 times 60, and I'm going to divide by 0.6. And when I do that, I'm going to get a value of 70 kilometers an hour. So that means that if it's a school zone, the car is definitely speeding, and the police can pull them over.